Hello everyone, welcome to LeetCode. In this video, we are going to solve another problem from the series Grind 169, and the problem is median of two sorted arrays. In this problem, we will be having two arrays of size m and n, which means size of both arrays can be different, they are not same. And we need to return the median of the two sorted array, which means we need to combine both of them, and then whatever will be the median, that median we have to return. But the catch is that the overall runtime complexity should be O of log m plus n. For example, input nums1 equal to 1 comma 3 and another one is 2. So by combining them, it will become 1, 2, 3 and 2 will be the median. Here, 1, 2, 3, 4, 1, 2, 3, 4. We combine, here will be the median. So 2.5. As all of us know, same median concept is used here also from our old schools. Our first approach will be using merge sort. So the straightforward approach is that we will combine both of them. Then we need to find out the median. If the total count is odd, then the median is at n by 2. If it is even, then n by 2 plus 1. As simple as it is. That algorithm will be, but we need not to combine both of them. We can use pointers for tracking them, and we will have two pointers P1 and P2 which will track. See, in the algorithm, we can see get total size of the array n plus n. If it is odd, we are looking for m plus n by 2. If it is even, we are looking for m plus n by 2 plus 1. So sub two pointers P1 and P2 on nums1 and nums2. Then you will start operating and finding. If both P1 and P2 are bounds and of the array, compare values at P1 and P2. If nums of P1 is smaller than nums of P2, move P1 and vice versa. If P1 is outside nums1, move P2 one place to the right. If P2 is outside nums2, just move P1 one place to the right and get the target element and calculate the median. As simple as it is. You will go for if m plus n is odd, you repeat step 3 by this one. And if it is even, repeat by this one. And here is our code. You will define the class and you will take variable, then you will create get min function, and here the find median sorted array. And you by following this, you can get the solution. But our complexity will be of O of log of n plus n. So we are going for binary search. Using binary search, we will change the some part of C. Because the inputs are sorted array and the problem asks for algorithmic time limit, we strongly feel that binary search is a promising method while we are not sure how to cast the same pattern as normal binary search on this problem. Let's go over some step of regular binary search and see if we can get inspiration. Using binary search, you will divide it. So we are coming to algorithm. Let's define a function that helps us find the kth smallest element from the inclusive ranges A star AN and B star BN from arrays A and B. For example, a range of A is empty. In other words, A star is greater than AN. It means all elements in A are passed. We just return the K minus A star element from the other array B. Vice versa, if B star is greater than Bn. Otherwise, get the middle indexes of two ranges. A index equal to A star plus An by 2, B index equal to B star plus Bn by 2. Get the middle values of two ranges, A value equal to A of A index, comma, B value equal to B of B index. Cut one array in half according to if A index plus B index is less than K, cut one smaller half. Otherwise, cut the smaller half of B. Otherwise, cut one large half. If B value is less than A value, cut the larger half of B. Otherwise, cut the larger half of A. In step 5, repeat step 1 using a new starting and ending indexes for indexes of A and B. Then we move on to find median elements and get the length of both arrays and A equal to length of A and NB equal to length of B. If total number of elements in A and B is odd, we are just use the above function to find out the middle element, which is K equal to NA plus NB by 2. Otherwise, if it is the even NA plus NB by 2 minus 1 and K equal to NA plus NB by 2 and return their average. And the same algorithm is coded here in the Java language. See, but by following this method, we can get the complexity analysis as let M be the size of array of num1 and N be the size of num2, whatever we have got in the question. The M complexity will be O of log min M comma N. We perform binary search over the smaller array of size min M comma N. Space complexity will be O of N, which is required and sufficient for our answer. Thank you for watching our video.